Hi guys, and welcome to today's class. This is our first class for this particular unit. And today we shall be familiarizing ourselves with the basic concepts in the subject of statistics. And we shall start by posing the question, what is statistics? And as some of you told me, is that statistics entails collection of data. It also entails presentation of data, the analysis of data, and interpretation of data. The only thing that you are not mentioning is that we do all that with an objective of making informed decisions. Okay, so informed decisions are useful in organizations, maybe at your place of work, and even in personal life. You may want to make your personal decisions by first collecting information about a subject that you want to understand. Then after gathering the information and analyzing the information, you make a decision, you make a personal decision in your life. So you find that statistics is both applicable or is both useful to individuals and also to organizations. So that is the same as saying that statistics is a group of methods or is a collection of methods that are used to collect, to present, to analyze, and interpret data. And the objective is to make informed decisions. Okay, so if one is not making informed decisions, of course, the opposite of informed decisions are maybe decisions based on ignorance, and nobody wants to do that. Okay, so we're saying, in addition, we are saying that decisions that are made using statistical methods are called informed guesses. Okay, and as mentioned earlier, is that if they are not informed, then they are out of ignorance, and nobody wants to do that, either in personal life or even at your organization. So statistics, we can say that statistics is broadly classified into two areas. One is what we call theoretical or mathematical statistics, and the other area is what we call applied statistics. So those are the two areas of statistics, theoretical and applied statistics. Theoretical or mathematical statistics deals with the derivation, the development, and proof of theorems, formula, laws, and etc. So if you know any formula that is used in statistics or any theorem that is applicable in statistics, then those are developed, they are derived and proved by the mathematical statisticians. Then on the other hand, the applied statisticians will use those theorems, the formula, rules, etc., to solve problems in the real world. So they use the formula and the rules, etc., to solve problems in the real world. And problems in the real world will be found in finance, in accounting, in international business, in procurement, in public management. You can think of any type of organization or any sector of the economy. There are some problems there that may need to be solved using statistical methods. That explains why all of you who are not mathematicians or statisticians are here studying statistics, because you may want to use some of the methods that you're going to learn in this class to solve some problems in your organization or in your life. Now, from the look of things here, it looks like our bias will be on the applied statistics. Okay, so we'll be looking at more details of applied statistics, and we'll notice that applied statistics can be further classified into two, the descriptive and inferential statistics. And for this particular class, our focus will be on one branch or one area of applied statistics known as descriptive statistics. So when you talk about descriptive statistics, we talk about obtaining both graphical and numerical summaries from sample data. The main tools that are used in descriptive statistics are tables. So you summarize sample data. Later on, I'll be explaining what is sample data, but it is important for you to note that in descriptive statistics, we work with sample information or sample data. So that data can be summarized in form of tables or using tables, or you can use charts or graphs or diagrams. And finally, you can summarize the same data using numerical values or using numerical summary measures. So the process of obtaining tables, graphs, charts, and numerical summary values from sample data is what we are calling descriptive statistics. So in short, what we are saying is that descriptive statistics has two main, let's say, areas like these. So you can use graphical summaries. You can use graphical summaries, or you can have numerical summaries. So when you have a bulk or maybe a large number of observations and you want to condense them or to compress them, you can condense them graphically, or you can use numbers to summarize that. But the key thing is that this information is coming from sample information, so of sample data. So that's what we're calling descriptive statistics. When you'll be writing your research project, a greater part of your work will be covering what we're calling descriptive statistics. So once you collect the data, you will try to summarize the data in form of graphs, either using pie charts, using frequency tables, and so on and so forth. Or you may use numerical summary values. You may calculate things like the mean, the median, the standard deviation, and so on and so forth. So all that is part of what you're calling descriptive statistics. So on the other hand, we're saying that inferential statistics comprises of methods that are used, or I mean that use the summary measures obtained from samples. You see these numerical summary values from sample data. Those are the descriptive statistics. So we use the summary values that we got from here to make predictions about some unknown population summary measures. I want you to note that there are two types of summary measures, numerical summary measures. Some of them come from samples, and those are the ones we are calling descriptive statistics, and others come from populations. Okay, so the summary values that are coming from samples are always calculated. That means they are known. We can figure them out. We can calculate them from the data. But the summary measures from the population, in most of the cases, they are unknown. And when you want to make decisions, you don't make decisions based on the sample information. You make decisions based on information from everyone in the population. So you need to have information about the population for you to make decisions. So what happens is that once you get this information from the sample, you use it to estimate this. And that is the process of inferring. That's the process of, or that's what we're calling statistical inference. So statistical inference contains some other processes, which we are not going to go into details in this class, like hypothesis testing and also estimation, either point estimation or interval estimation. Okay, so basically when you talk about a statistical inference, we talk about using the sample information or the summary measures obtained from the sample to make predictions or estimations about unknown population parameters, because it is with these population parameters, the estimated population parameters, that we are going to make our decisions. So basically, That is the concept of statistics and how statistics can be classified. I want us to summarize that information in a flow chart as shown below. So that's a flow chart showing how to classify statistics. You'll notice that we are not concerned with this bit. So we shall just be using theorems and formula that have been already derived and proved by the mathematical statisticians. Then in this class, our focus will be on the descriptive statistics. So this class falls here. We'll be dealing with descriptive statistics. That means that we shall be working with sample data. Then from that sample data, we try to summarize it in form of tables, in form of graphs, in form of diagrams, and so on and so forth, and also in form of numerical summary measures. So these numerical summary measures are the ones you saw in the course outline in the name of measures of central tendency, measures of dispersion, measures of skewness, and so on and so forth. Then inferential statistics is at another level, and we will not be discussing it in this class. So the first of the terms, of the other terms that we're going to look at is the term population. And the term population is, the definition of this term is quite similar to the definition of the universal set, where the universal set is a set that contains all the elements or individuals or items or objects that we are interested in. So in the context of statistics, we may define population as a complete set of all the elements or individuals that we are interested in a given statistical inquiry. Then the population that we are studying, or the population that is being studied, is usually called the target population. I want us to have an illustration of a target population from the example below, or from the illustration below. So suppose you want to study the time taken by students to complete a certain exam, okay? So in that case, your target population will be all the students who are registered for the said exam, all of them, without leaving out even a single one. That's what we are calling a target population. So in other words, it's a complete set of the individuals that we want to study in a given problem. Now, if you take a subset, you find that in most of the cases, it is quite inconvenient for you to try and get information from the entire population. In most of the cases, you'll find that some elements of the population are not available for study. So it means that if you have to wait until you get information from all of them, then maybe it may take a lot of time, and possibly the information that you want to get will be stale, or it will be no longer relevant. So to avoid such challenges, we usually work with subsets of the population. And usually these subsets of the population are chosen in such a way that they have all the characteristics of the population. These subsets of the population are called samples. They are called samples. So let's define a sample and possibly give an illustration to show what is a sample, and then we move on to other terminologies. So as mentioned earlier, is that a sample is just a portion or a subset of the population. And in most of the cases, we prefer a sample to be representative, or to have almost all the characteristics of the population. Now, other terminologies that we are going to define are terminologies like a survey, a census, and so on and so forth, where we say that the process of collecting information from either elements of a population or elements of a sample is called a survey. Okay, and if you conduct your survey on the elements of a population, then you end up with what you call a census, or complete enumeration. So that's a census on all the elements of the population. If you conduct a survey on a sample, then you end up with what we call a sample survey. And there are cases, and usually this is very much recommended, where you select your samples in such a way that every element in the population has equal chance of being selected. Then the sample that comes out of such a process is what we call a random sample. Okay, so when you talk about equal chance of being selected, it means that there's no bias. Okay, there's no bias in the way you pick the elements of your population into a sample. There's a problem if your sample is not random, because if the sample is not random, technically that just means that your sample is biased. Okay, or some people are more favored to join the sample compared to others, and vice versa. So if your sample is biased, it means that the summary measures or summary values that you're going to get from such a sample, they will also be biased. And the conclusions that you're likely to make out of those sample summary values will also be biased. And if there are any decisions that will make out of the analyzed results, they are also likely to be biased. So to avoid biases, you need to pick random samples, or to pick elements from the population in a random way, okay, or in a random fashion. The other term that I want us to look at is a variable, the meaning of a variable, and the various ways of classifying variables. So when you talk about a variable, we refer to a characteristic and a study. And the study we're talking about here is a statistical inquiry that takes or that assumes different values for different individuals or elements in the sample or in the population. And to make it clearer is that the opposite of a variable is a constant. So if the attributes that you're interested in are not changing from one individual to the other, then we call that a constant. It's not a variable. And usually in statistics, we are only interested in variables because we want to observe the changes in the observations, and then we try to predict some other attributes of interest. And I have two variables here with me, the age of students in this class. And clearly, if I were to record the age of every student in this class, I will get a different value for everyone. Possibly, there are people who are the same age if you were to round off, but you find that for many people, their age is quite different. So in short, the age of students in this class is not the same. So this qualifies this to be a variable. So this is a variable. This is a variable. But if you look at the second statement here, this is subject to correction. But from my little investigation, I know that all the students who are in this class are from the same nationality. Okay. So if everyone in this class, for instance, is a Kenyan, then the nationality of students in this class is not a variable. So the nationality of students in this class is not a variable. If at all, this statement is correct. I'm assuming that nobody in this class is coming from elsewhere. I know there are classes where we have students from other countries, but for this particular one, I'm sure there are no students from other countries. So this is not a variable. So if you are collecting data from some people, and it happens that one of the attributes that you're interested in is not changing for everyone that you are targeting, then that's no longer a variable. You need to drop that particular question from your questionnaire, okay? Because it doesn't add value. So that's what we call a variable. Let's look at the types of variables. We're going to say that variables can be broadly classified into two. That is quantitative variables and qualitative variables. So, so as mentioned, we have quantitative and qualitative variables. Now, when we talk about a quantitative variable, we are talking about, or we are referring to a variable that can be measured on a numerical scale, or whose values or observations are numbers, okay? And the data that comes from such a variable, is called quantitative data. So from quantitative variables, we get quantitative data. Then we're also mentioning that quantitative variables can be further classified into two. That is, discrete variables and continuous variables. When you talk about discrete variables, we refer to quantitative variables whose data takes some specific values, some specific numeric values. And in most of the cases, they will take whole number values, though there are special cases where the numbers are not whole numbers. When we talk about the continuous variables, these are quantitative variables whose data takes any value within a given interval, meaning that continuous variables take both whole numbers and fractional values. So let's note that. So examples of a discrete variable, we can have this example, the number of students in different classes in the university. Okay, so if you are to visit all the classes in the university and record the number of students who are attending classes there, then we expect that the data you collect there will be non-negative values. So we expect numbers like this. Maybe there's a class which has no students, a class with 1 student, all the way, a class with 100 students, and so on and so forth, etc. So the important thing here to note is that the values will be non-negative. Non-negative whole numbers, in this case, for that variable. Okay, you may think of another example, like if you are studying the average number of children per family in a certain estate in Nairobi. So if you record the number of children in the sampled households, then you also expect the numbers not to have negative values and also not to have decimals. Like you don't expect a family which has 2.5 children and so on and so forth. It doesn't make sense. The same case with the number of rooms in a house. We expect that to be a whole number and possibly a number starting from 1 going up, no 0. Okay, so you find that those are variables which are taking some specific numeric values. Okay, there's another example here I like giving, the shoe size of students in this class. You notice that shoe sizes sometimes are given as a mixture of whole numbers and their corresponding halves. For example, you can have a shoe size number 1, number 1.5, number 2, number 2.5, etc. But you cannot find any other decimal except 0.5. So you cannot find a shoe size 3.287 or 1.238. You only find some specific numeric values. So again, in that case, though the shoe size is not taking strictly whole numbers, it is taking some specific numeric values. Okay. So on the other hand, we're saying that a continuous variable is a quantitative variable whose data takes both whole numbers and fractional values. It takes any value within some given interval. And a good example is the height of students in this class. Okay, if I were to measure your heights in centimeters, maybe some of your heights are an exact number of centimeters. Others are maybe with some decimals and so on and so forth. The same case with this example here, the time taken for you to finish a given test. Some of you maybe will take 1 hour, others will take 1 hour, 10 minutes. So that's 1 hour point something. So the data here takes both whole numbers and fractional values. So those are what we call continuous variables. And the data that comes from there, of course, is called continuous data. Just like in the case of discrete variables, the data that comes from there is called discrete data. Okay. Now, those are quantitative variables. Then the opposite of that is what we are calling qualitative variables. They are also called categorical variables. So in short, qualitative variables are variables which cannot be measured on a, or whose values cannot be measured on a numerical scale. So in other words, we are saying that a variable that cannot assume numeric values. And there's something we are adding here, but can be classified into 2 or more non-numeric categories. You can classify it into 2 or more non-numeric categories. Then that variable is what we call a qualitative or categorical variable. And the data that comes from there is, of course, qualitative or categorical data. Let's have a look at some examples of qualitative variables. Number one, you can think of something like the district of birth, your district of birth. If I were to record your district of birth, if that is my variable of interest, then all the answers or the data that I'll get from that variable will be names or labels. Maybe some of you come from Nairobi. Maybe there's a district called Nairobi. Yeah? Maybe some of you will come from Machakos. Maybe some of you will come from Lamu. Maybe some of you will come from where? Yambu. etc. So this is data which cannot be measured on a numerical scale, district of birth, okay, and many others. Number two, another example is the gender. Suppose in my survey, I also want to know the gender of the respondent. So some of them will say they are females. Others will say they are males. You see? Number three, maybe the last one, the race. Maybe some people will report that they are blacks. Others will mention that they are whites. Maybe they are Hispanics, etc. So this data is what we're calling qualitative or categorical data. We need to note that qualitative data takes the form of names. Takes the form of names or sometimes labels. Okay. For example, a name like this, that's a name. Or you may use a label like this. For the same, you may use a label like this. F, that's a label. Okay. Or a name like this, black. Or you may use this label, B, for black, and so on and so forth. Okay. Then in addition to that, we need to say that these type of variables, that is qualitative variables, can either be nominal. We can have nominal. They can be ordinal or ranked. Okay, so we're going to look at each one of them and possibly give an example in each case. So when we talk about the nominal variables, these are variables whose data takes the form of names or labels, and these names have no natural ordering in them. An example is gender. Okay, gender, which is either male or female, you notice that it is not possible for you to arrange gender from the smallest gender to the largest gender because there's nothing like that. The same case with color. Like, for instance, if the question of interest is the color of the eyes, black, blue, green, etc., it's not possible for you to arrange this data here from the smallest color to the largest color. So we would say that color of the eyes is an example of a nominal variable. The same case with gender. Now let's look at the other variable, which is ordinal variable, and see how it looks like. So ordinal variables, in this case, the data takes names or labels, but unlike the nominal case, the data here or the observations here have a natural ordering in them. And a good example is the level of education. So if somebody indicates that they have completed up to primary level or secondary level or tertiary level, it is possible for us to arrange this data from the lowest level of education to the highest level of education. Okay, so that's an example of what we call ordinal variable. Maybe another example still under here would be maybe the grade scored, the grade awarded or in KCSE or in a certain exam. Maybe the grades are looking like this. It's a label, another label like that, another label like that, like that. So it is possible for you to know what's the highest grade, followed by which one, and so on and so forth. So in this case, we would also call this one an ordinal variable. Then finally, we have what we call a ranked variable or ranked variables. Ranked variables. So unlike in the ordinal variables where the ordering was natural, in the case of ranked variables, the ordering is not natural. It is assigned by the researcher or by someone. So these are just nominal variables, but now you assign ranks to the different categories. You assign one category as maybe your rank number 1, and so on and so forth. For example, if you look at the example on the district of birth, you can assign maybe, let's say, Nairobi as your rank number 1. You can rank that district as number 1. Maybe Kisumu, you can rank it number 2. Maybe Lamu, you can rank it number 5, and so on and so forth. So the difference between the ordinal and the ranked is that the ranks are usually assigned, unlike in the case of ordinal where the ranks are natural. Okay. So basically that is it. That is the way you classify variables. I want us to summarize all that in a flow chart, like the one we did for statistics, and then we should be done for today's class. So in summary, this is how we can classify variables into either quantitative or qualitative. Okay. And then under quantitative variables, we have either discrete or continuous. Then for qualitative variables, we have either nominal, ordinal, or ranked variables. It's good for you to note that this is also the same classification we have for data. So data can also be classified as either quantitative data, qualitative data. Then under quantitative data, we have discrete data and continuous data, and so on and so forth. So to conclude, please look at this assignment. Look at it after the class. So that also marks the end of today's class. Let's meet again next week. Thank you.